plus minus under root of b square minus 4 times ac divided by twice b. So
Okay, we will start the lecture.
calculate the roots, but we will be using this particular expression. We will be going with the bisection. Okay. Now, in the bisection method, if you remember, what we have to do is first of all we have to choose 2 points. Okay, 2 points such that the one point
Is the screen visible to all?
Positive side, like shown in this particular figure, and the another point should be on the negative side. Okay?
Yes, please let me know. Is the screen visible to all?
And then only we can show all the possibilities. Okay. So let us try to find out the values. Okay. So for this purpose, what I do, let me choose, let us say x equals to, let us say 0.
And we will take a few more examples.
Because this x will be 0, this 2x will be 0, and only 4 will come into picture. This will be plus. Okay. And if you choose, let us say x equals to 1. In that case, the value of y, this will be 1 square. Okay, 1 square will be 1 minus say 2x. Okay, so this will be minus 1. Okay, minus 1 plus 4. What is this?
This is 45 degree. This is 30 degree.
Sorry.
These are smooth inclines.
Okay, and if you choose x equals to 2, what will be that?
This is 12-meter bar. This complete bar is of 12-meter length, and there are few loads which are acting on this bar. The distances are mentioned to be 3 meter, 6 meter, 3 meter. Total is 12 meter. These loads are given as 200 Newton and 300 Newton. So the given information, weight of the bar is 0. That is, it is of negligible weight, and it rests in position as shown in figure on smooth inclines. You are supposed to determine the angle theta when it is in position of equilibrium. Okay. So you are supposed to identify this theta angle. This is unknown. This is what you are supposed to identify in this numerical. So the thing is, you are supposed to identify the forces which will be developed at various locations. So you can see this bar is in contact at 2 locations. First point, let's say point A and point B. Okay, and over here you will expect reaction forces. The reaction forces will be perpendicular to the contact surface, right? So over here, let me call them to be reaction at A and reaction at B. Okay? These are normal reactions, which are perpendicular to the surfaces like this. You are supposed to identify this theta. But while identifying this theta, you will come to know that there are 2 more unknowns, that is RA and RB. What you do, you draw the sketch which will represent the unknown parameters. So let this be RA, okay, and this shall be RB. Okay. And these are the 2 loads which are given. Distances are 3 meter, 6 meter, 3 meter, 200 Newton and 300 Newton respectively. This is what is given. One more thing is this theta, which is still unknown, that has to be found out. These are inclined forces, as you can see over here. With respect to this XY axis, these are inclined forces. So what you do? To resolve the inclination into components. So can you please let me know what will be this angle? If this is 30 degree, what should be this angle?
Now, if you observe carefully, this is of order
Please let me
3.
know what should be the value of this angle.
Since it is of third order, it will be having how
Yes.
many roots? 3 roots. Okay.
What should be
So
the
we need to find
angle
out
value
at least
over
one
here?
root from this. Okay. So again, we are going with some parallel.
Are you people there?
Just try to find out what is the value of y.
Hello.
X value equals to 0.
Yes, sir.
So what should be the value of this angle? This is 30 degree given.
Here also 0, here also 0. So you are going to take as minus 2.4.
How much should be this value? And accordingly, how much should be this value? जल्दी बताओ. Please inform. Anyone? Yes.
Sorry.
What should be this value? जल्दी बताओ.
0.6.
Come up.
Fine. And if you go with x equals to 2, what will be the value of y?
ठीक है. Anyway, I will call this as alpha, and I will call this as beta. As per your understanding, you find out the values of alpha and beta.
Minus
This will be RA cos of alpha. This will be
plus 4.
RA
Okay.
sin of alpha.
Successfully
This will be RB cos of beta. RB sin of beta. Right? You know the distances.
So if you got a curve, what you are going to get is like this.
There are 3 unknowns.
So you have a point.
From the equation, it is confirmed that there are 3 unknowns. That is RA, RB, and theta. So, using equations of equilibrium, since this complete system is in position, you use summation of force in x direction equal to 0. How many values are there? RA cos alpha, which is positive. RB cos beta, this is negative, equated to 0. Summation of forces in y direction equal to 0. RA sin alpha positive, RB sin beta again positive, minus 200 minus 300 equal to 0. Okay, this is equation number 1. This is equation number 2. These are framed. Now the next is finding out the third equation, that is taking moment. So you can take moment about any point. Let's say summation of moment about point A equal to 0. How many forces? 200. So this will be 200 into, with my understanding, I am writing down the value. You can verify that later on, because you are not responding. You people are not responding to what I am asking. So this will be the perpendicular distance. It will be, as per my understanding, it will be 3 cos theta. Then this is going to rotate about the point A in the clockwise direction.
Yes.
Then this will be the force 300. Again, 300 into 9 cos theta, which will again rotate about point A in the clockwise direction. Whereas at point B, you will find there are 2 forces. And both these forces will revolve or rotate around point A in the anti-clockwise direction. So this will be minus RB cos beta into the perpendicular distance. RB cos beta will be associated to 12 sin theta value, right? Similarly, RB sin beta, RB sin beta into 12 cos theta. Okay, so this will be the equation number 3. So this is how the equations will be formed you are supposed to substitute alpha and beta values. क्या होगे? Again, I am asking you people, what will be the values for alpha and beta? कितना है अल्फा पे कितना है वैल्यू? Am I audible?
So what exactly is happening over here is
Yes. Hello. Students, are you there?
you have a curve which is going like this, and
Yes. So can you please let me know what are the values of alpha and beta in this free body diagram?
and your xm is coming somewhere over here, so that its corresponding ym is now positive.
जल्दी बोलो.
Okay. So now you have now 3 points. One is the P1, one is the P2, and then let us say.
ठीक है. If anyone is not responding, I will consider this to be your assignment number 1. You are supposed to solve this and the subsequent problems in as assignment number 1. You include all of them in assignment 1, and you are supposed to submit everything on 26th. Okay? So you are supposed to identify the theta value and find out the final answer.
Will be now in first value here you have got this 1. Okay. So 1 plus 1.5 divided by. Again it is now 1.25. Correct? Find the value of y please. Find the value of y please.
Second question.
Zero point 1781. Is it positive or negative? Positive. Okay. So here also it is coming out to be positive. Okay. So then again we have to bisect.
This is again a rod
Negative value.
whose dimension and
So
whose length
for the
is
third iteration,
10 meter, and it rests on such kind of surface.
iteration 3
This is a horizontal surface.
will be
This is
one
an
more time,
inclined
1 plus 1
surface,
25
and the slopes associated to this is
1.125, I suppose.
3 vertical, this is 3 vertical and 2 horizontal. Okay, this is the inclination, which is given as 3 vertical, 4 horizontal. Okay, this is mentioned. One more thing which is given is there is one force which is acting over here. This force magnitude is 60 Newton. You are supposed to identify this distance, this much, x distance. Okay, so the problem statement, find the distance x. Find this distance x.
Okay. So now you see for the first time
This
we are
distance,
getting the
x.
y value as negative. This means
Measured
the
along-
y value is somewhere over here. Okay.
Measured
So now for the
along
next iteration,
AB,
you need a point
at which the
is
horizontal
on
force
both these
of
sides.
60
For
Newton
iteration number 4,
should be applied to hold the uniform bar AB
the
in
exit value
position.
will be such that one should be negative and one
Okay.
should be
The weight of
positive.
this
Remember,
bar,
in the earlier case, the value of y
weight of
for
bar
value of x as 1 was negative.
AB
And the value
is
of
given
y
as 140
was
Newton.
positive.
That means the self weight is mentioned
Since
over
the
here.
value of y is negative, we have to take the positive value over
So how many reactions do you expect? One reaction force, again it is a normal reaction acting at point A, and normal reaction acting at point B. This will be an inclined reaction force. Let me call it as RB. Let me call this to be RA. So as per the information related to the slope is given, you please calculate this angle value. Let me call it as alpha. Okay? Now I will draw the free body diagram, and that is a sketch, single line sketch, which will represent all the essential external forces, right? So this is RB, RA, then this is 60, and this 60 force is horizontal force. 60 Newton, this is horizontal, and you are supposed to identify this X distance in order to keep this complete rod or complete bar AB in position. One more thing is given that
So you see
self weight
the value of y
140 Newton
very close
is acting. This self weight will be acting exactly at the center of this rod. How much is the total length? 10 meter. So this is 5 meter. This is 5 meter. Okay. Next. You know the slope. So what you can do is you calculate this alpha. This is again homework or assignment which you are supposed to solve. This is alpha, and you also can calculate this inclination with respect to the slope which is given for the rod or bar.
So here I will say x1.
So you will get this angle. Let me call this angle to the beta. So alpha and beta can be calculated.
We have started with x12 as 1 and the corresponding
Can be calculated using
I think it was
the
minus 0.6, right?
slope
And the x2 value was
conditions,
and the corresponding value of y.
slope conditions
You
given
can see I'm talking about this
in the
one which is
numerical.
shown with the blue rectangle.
Okay,
So now
you can identify alpha and beta with the help of this slope information, whatever is given. You can find it out, right? Now,
show you the x and y. So when for the first time when we have gone for the bisection 1 and 1.2,
you extend this thing so that it will be easy for you people to identify the distance, because you can see again there are three unknowns, RA, RB, and this X term, X. That's what we need to find out. So make use of summation of forces in X direction equal to 0. How many forces? This horizontal 60 Newton minus this, which is RB cos of alpha. Alpha can be easily found out. You can calculate it, equate it to 0. Similarly, summation of forces in y direction equal to 0. RA plus RB sine of alpha minus 140 equal to 0. With this, we cannot calculate any of the values because there are three unknowns, right? Alpha, RA, RB. Take moment. Moment about point B this time, because if I take moment about point B, I am eliminating two forces. If I consider this, in that case, moment about point B equal to 0. So RA into the complete distance shall be 10 cos of beta. Tick 10 cos beta, which is rotating in the clockwise direction. 140 Newton will cause a moment of anti-clockwise about point B. This is point B. This is point A. So what's happening? 140 into perpendicular distance. What is that perpendicular distance? 140 into, this is the perpendicular distance. How much it will be? 5 cos of beta, anti-clockwise direction. There is one more
Excuse me,
term.
sir.
Yes,
Sorry, 1.2.
Sir, is beta equals to 36.86?
yes, beta is 36.86. Correct.
1.875.
That is correct. What about alpha?
Negative 0.0426. Okay. So you see the y value. Okay. The y value. Our aim over here is we need to find
What is
out
alpha value?
x such that the corresponding value of y should be close to 0. So in the first iteration, the value of pi n was 1.2. So for the time we need to forget about this sign.
Yes, what is alpha value? Please let me know.
Reaching
If you have calculated this, you can also calculate this alpha value. Please let me know.
Then again it is reduced. So slowly it is reducing, and if you go for one more cycle, definitely you are going to get the one good result. Okay. So now can you tell me what should I write in x1 and y1 from this in the next cycle? What value should I take?
कितना है?
56.3.
Yes, 56.31. Correct.
What value of x1 should I take?
So you know alpha and beta values. Right now I will frame everything with respect to alpha and beta values only. Later on you can substitute these values and find the final answer. Will this be okay?
Yes, students, please respond. What value of
Will this be
x1 should I
okay?
take?
Yes or no?
Yes, sir.
ठीक है. What is the remaining thing now? This 60, because this is also a force which will contribute in the moment equation. So I am taking moment about point B. So if I extend this line of action of force, okay, what will be this much distance? Can you please let me help in finding out this much distance?
1.1875 and 1.25.
Because this will be the perpendicular distance associated to
Also, there is a value
this
of
force.
that is
So can you please let me know what should be this value?
y amount.
Can you identify this distance?
Okay.
How much is this? See, this is x. This will be x cos of 36.86. This will be x sine of 36.86. Am I right? This much.
0.06.
So what according to you should be this much value? See, complete length is of 10 meter. So, huh.
So that we can see the y value is now going to be closer to 0. That is 0.06.
This complete distance, isn't it? But what I'm asking this much.
This is 0.06.
So this will not
So now
will not just be
right in the next row.
10 sine 36.86 minus
1 point.
x sine
Okay.
36.86 बराबर है क्या? If I am wrong, please correct me.
Okay. Because this value is positive. Okay.
I am finding out this much distance.
Okay. So this go for bisection.
Is this okay? I am finding out only this much.
1.203. And what about this one?
Is this okay or not?
Yes, sir.
So if this is fine, then 60 to this perpendicular distance will rotate about point B in the anti-clockwise direction. So minus 60 into 10 sine 36.86 minus x sine 36.86. Anything else? We have considered Rn, we have considered this force, and we have also considered the self-weight of the bar. Equate it to 0. Substitute the values for alpha, beta, and find out this
the
X
final
value.
answer will be 1.2. Okay.
Can you do
And
that?
the corresponding y value is 0. Okay. But here you see to reach 1.2.
So before calculating
even
X,
more number of cycles.
can you please let me
Takes a
know
lot of time. That's why
what is the value of,
basic method of bisection.
let's say, RB? RB कितना था? Because you have got alpha value.
108.1.
That's why
अच्छा, RB you are getting it to be 108 point.
different some higher order.
How much?
So
108.1
something.
अच्छा.
Just different now. So
And what about RA?
for example, so this completes. Okay. So now you try to understand. Okay. So we have chosen, let us say we have a curve, which is something like this. So we go up and then we go back.
That 50 point
Now, as far as this method is
कितना?
concerned, we have to choose 2 points, right?
50, 50.
Choose 2 points in such a way that both points should be
तो एक काम करो. See what I have told you. I have asked you to calculate this alpha angle.
For example,
आपने मेरे हिसाब से ये एंगल कैलकुलेट किया है, if I am not wrong. बराबर है?
you choose another point somewhere over here.
That is this angle. Let me call this angle to be theta.
Choose this.
So tan theta is equal to 3 by 2. बराबर है? And theta then comes out to be 56.31. यही फाइंड आउट किया आप लोगों ने? बराबर है क्या?
Yes, sir.
But what I asked you, I asked you to calculate this alpha angle. This alpha angle will be nothing but 90 minus 56.31. Got it? कितना आता है वो? How much is this value?
So what you have done, if you have chosen a point which is
बराबर है क्या?
away from
33.69.
Yes, sir.
you have 3
है ना?
iterations.
So you please do the necessary change in the alpha value and please recalculate the RB value.
Okay. इसकी कोई जरूरत नहीं थी. If you have chosen a point somewhere over here, in that case, these 2 iterations they were not even required. Okay. So one of the biggest problem is that if you choose guess roots, okay, P1 and P2 they are not equal to guess roots. So if you choose
So
a guess
RB will be equal to 60 divided by cos of 33.69.
So this is one of the biggest drawback of this particular method. Okay, so please note that. Okay. Otherwise, in general, the method requires many iterations, but in one moves we even increase if you choose the points which are far away from the.
बताओ कितना है?
Okay.
RA, sorry, RB.
Anybody having any doubts? Please let me know.
जल्दी जल्दी बताओ बेटा.
Yes. Yes, students, are there any queries?
Please inform. RB कितना आ रहा है?
Sorry, can you please louder?
72.11.
Okay,
See, in the
72.11.
exam, what will be
And
asked is
accordingly RA कितना आता है? अभी बताओ. Alpha is now 33.69. Substitute that value. Find out.
Okay. So all we have to
I
do
think
is
you should
find
use
y value. So unless
100 Newton, बराबर?
y is close to 0.001 or
हाँ.
0.01.
Now you substitute this value over here.
Is it okay?
Everything else is known to you. Beta is okay. Beta is straightforward value 36.86. So you please substitute the value and please find out the value of x.
Okay. X2 minus 1.5 x square. Okay. So we take one more power.
Last numerical for this thing, equilibrium condition. And if you remember, we have discussed the numerical problems wherein there was no friction associated to it. Everything was resting on smooth surfaces, right? And because of that, additional equations were eliminated. We will be discussing those numericals which will consist of frictional resistance, wherein you will find some additional reaction forces, they also come into picture. And the number of unknowns, they may increase because of this addition, right? Before going to that, let us complete our equilibrium without friction with this numerical.
On the left hand side or on the right hand side of the 1.5. Okay. For example, just to start,
someone has calculated the answer, I suppose.
Okay. So what is the value of y? Can someone tell me? This will be definitely 0.
1 minute.
Because x is 0, this is 0, so this will be completely 0. Okay. And just you can see this is one of the rule.
Rule number 78.
हमको क्या चाहिए? We need the value of x such that the corresponding value of y should be.
This is the numerical.
This is 1. So your x1 will be now 0. This is the rule 1. Okay. So if you go for another rule, okay, let us say the value of x equals to let us say 1. Okay. What will be the value of y? Can anybody tell me? Minus 0.5, I suppose. Okay, so this is negative. Okay.
This is
and
hinge.
If you choose x value as say 3,
this is again hinge.
So I am choosing this as 3. Okay.
This
Can
is
you tell me what will be the
roller. This is 500 Newton load. This is this consists of trapezoidal loading.
27 minus 1.5 times 9. How much is that?
Like this. This is a uniformly varying load condition.
So you can see this is negative and this is positive. Okay. So what
Uniformly varying load. Over here you can find the notations to be
like this.
AB and CD. So there are two different beams. One is beam AB, another one is beam CD. Intensity of this uniformly distributed load, this is 100 Newton per meter, and this intensity is 200 Newton per meter. Distances mentioned are, this is 4 meter, then this is 4 meter, this is 4 meter. From here to here, this is 8 meter. This is what is given. You are supposed to identify the reactions at A, B and D. A, B and D. So in this numerical, as you can see, there are two hinges. This is hinge number 1. This is hinge 2. So at hinge, you will expect two reaction forces, RAH, RAV,
this is minus 0.5.
RDV,
This is 2 and this is
RDH.
so the value of y.
How many unknowns are there? Right now there are 1, 2, 3, 4. In addition to this, you have got this reaction at B. So there are 5 unknowns. On the top of that, you will find that there is a roller support which is included over here. So this will also exhibit some kind of reaction force. But the advantage of this complete figure is that we are in a position to separate these two beams, that is beam AB and beam CD. So let me draw the free body diagrams associated to each.
There is root 2 and there is root 3. We have already calculated root 1.
This is, let's say, AB, beam AB.
So,
and the reactions, those may get developed at point A. RA horizontal, RA vertical. This is 500 Newton load.
Yes, students.
Then at point C, as we have already discussed earlier, you will expect the reaction RC to be developed in this manner on beam AB, whereas equal and opposite reaction force will be generated on member or beam CD. Okay? So member CD will be something of this sort. CD, right? At B, you will expect only one reaction force because it is a roller support. So this is RB. At point D, you will be expecting two reaction forces. So I am assuming the direction of these forces initially in this manner, right? So the total distance, if you measure the total span of this CDB, how much it will be? 8 plus 4, that is 12 meters. This is 4 meter, this is 4 meter, this is 4 meter. So now you can understand, if we consider the free body diagram of AB and CD separately, these can be easily formed out by using equations of equilibrium. Three unknowns, 1, 2, 3, and 3 equations are available with us. So step by step, for beam AB, free body diagram is available with us. You make use of equations of equilibrium and jot down all the equations. So you can see RAH equal to 0. Can you see? For this system, that is for beam AB, there is no other force than RAH. So therefore, RAH is equal to 0. Summation of forces in y direction equal to 0. How many forces? 1, 2, 3, and 4. RAB plus RB minus RC minus 500 equal to 0. Correct? So there are three unknowns: RAB, RB, RC. RAH got eliminated because we know there is no other horizontal force. Then this comes out to be equation number 2. What you do? You take moment about point A. Formulate the equation. I will write it down for your convenience. 500 into 4 plus RC into 8 minus RB into 12 equal to 0. So this is equation number 3. Now see what happens. RC is still unknown. This can be calculated if I consider for beam CD. Now on beam CD, you can see there is uniformly varying load. How to treat uniformly varying load? This is the condition which is given, trapezoidal loading. What you can do is you can divide this trapezoidal loading into two parts. One will become triangular, another will become rectangular. This is triangular, this is rectangular portion, right? The intensity is given as 100 Newton per meter. This will again be 100 Newton per meter, and remaining portion it will be 100 Newton per meter. These such kind of uniformly varying loads, they can be modified in the form of point load in this manner. So for this rectangular portion, the intensity of the concentrated load will be acting at its centroid, that is at the center. How much is the total length? It is 12 meters. So this is 6 meters. Similarly, for this triangular portion, the load shall be acting somewhere here, and the distance from this point D how much it will be? 1/3 of the distance, which is 4 meter. Am I right? So this you can extend up to this much, this distance. What will be the intensity of this load? It will nothing but the area of this figure, right? So let me call this as intensity A and intensity B. So intensity A, the magnitude of this intensity A shall be 100 into 12, that is 1200 Newton. Similarly, intensity of B, how much it shall be? Half base into height, which is nothing but 600 Newton. And this 1200 Newton is acting at a distance of 6 meter from point C, and intensity of 600 Newton is acting at a distance of 4 meter from point D. So I will be placing these 2 point loads over here. This is 6 meter and this will be at a distance of 4 meter. Remaining distance is of 2 meter. This intensity over here is 1200 Newton. This is 600 Newton. So from this, for beam CD, what equations do you get? If I apply equations of equilibrium for beam CD, summation of forces in x direction equal to 0. RDH, it will be 0. Okay. Then forces in y direction, RC plus RDV minus 1200 minus 600 equal to 0. This will be equation 2. And in order to find out one of the values out of this, either RC or RD, we will be interested in finding out RC, because in our earlier equation, this was unknown. So what I will do, I will take moment about point B equal to 0. RC into 12 minus 1200 into 6 minus 600 into 4 equal to 0. This will give me RC value. And once I get RC value, I will get this RD value also. What you do, you substitute this RC in the earlier equation. And from here, it is very much evident that RC value comes out to be positive. So my assumed direction over here, it is correct, right? So without modifying any of the values, I will simply continue with the value which is obtained. I will place it over here and then I will calculate the RAV and RB value. So is this understood to all? You can consider this problem to be your homework or assignment and you solve it. Homework कहने से अच्छा you include it in your assignment. ठीक है? Assignment number 1 and you are supposed to submit. ठीक है? So you people can leave. In the next class we will discuss another chapter. Thank you.